you have to do in order to head north on the globe.
But have you calculated how much of a force or acceleration that would be, and whether that's within the sensitivity of the maps?
Yes. MEMS are about 1,500 times more sensitive than necessary. It's
Okay.
0.015 meters per second squared.
What
And
are these things
how
used
fast
for?
are you? I was just gonna say, how fast are you assuming the plane's going north?
That's assuming a normal airplane of 500 miles an hour.
Okay.
My whole issue with this is if the plane's drifting, like, okay, say we're in a plane and we're in Canada and we're heading south towards the equator, which way is the plane going to drift?
It will drift. You have to accelerate to the. Oh shit! You have to accelerate to the east. I'm not sure.
It doesn't matter. In one way, if you're going from the top of Canada to the equator, right? In one scenario, you're going to be constantly chasing your target because you're going to be drifting one way. In another scenario, you're going to be able to lead your target and land right on it.
Right. And so basically what you would see is you have to accelerate to the east.
Flight times. We would see this in flight times.
No flight times. No, yeah. Well, no flight times necessary. I mean, you would, but it'd be
Why?
You're both directions. You're going to have to account for 2 miles an hour of drift. So one's going
but in one case,
one way, one's going to be drifting the other.
I know, but in one case, you're going to be constantly trying to catch up to the city you're trying to fly to, and in another case, you'll be able to just lead it. Like the plane can fly into the city essentially, whereas in one scenario, the plane's going to be constantly trying to play catch up.
Well, in this case, all of that stuff goes away. Not necessary. All you do is you hook up the MEMS in there. You set it to just do horizontal, not horizontal, to do lateral motion. And now you fly your plane up north, and after about 1 second, you can tell how much drift there is, and any duration that you want. You can go 10 seconds, 20, an hour.
I feel like you need to average it over a little bit of a longer time to make sure it's not.
Yes, right.
These MEMS detectors, well, they measure electromagnetic fields, yeah?
No.
Okay, so I just Googled it, and that's what came up. So
they measure the motion of internal masses as they move back and forth.
Okay, hold on. I want to put the wrong thing in Google. I put in MEMS, a MEMS sensor. Is that not what it is?
MEMS accelerometer. I'm not sure if there's other MEMS.
Okay,
what
then
does
hold
MEMS
on.
stand for? Now, if you want to go to the internal workings of it, how it determines that, well, the mass moves left to right, and it either changes a resistance or a capacitance based upon that motion. Could even do a pressure. You could have a load sensor in it that would measure the pressure.
Do you understand what I'm saying though about going north south? Like I know you can follow this.
Well, no, actually, I don't agree with what you're saying, but I'd have to think about it a little bit more.
In one scenario, my bad. Listen, just hear me out. In one scenario, okay, imagine we're shooting a bullet. Target. Scenario that you're never mind. I can't do the bullet thing. I don't when you're
even the bullet.
I can't relate it to a bullet because it's got to be a. Yeah, it's the same. It's the same thing, though. But okay, imagine you're shooting a bullet in one direction. if you shoot south, you're going to be leading the target. I don't know which way it actually is, but let's say it's you get to lead the target shooting south, right? And in the other scenario, it's going to be drifting the other way. So you'd have to
In
shoot.
both cases, I have to accelerate 2.1 miles per hour. Or I should say, I have to change speed by 2.1 miles per hour per minute. So I'm going to be either changing it east to west and west to east. It's still both directions. You're going to have to do that acceleration because you're going to have to get the plane up to 1,000 miles an hour or down from 1,000 miles an hour, depending on the direction you're going. So it's going to be either an acceleration or deceleration.
I'll figure it out and I'll put it down because this is a. Yeah. I'll figure it out and I'll put it down because this is actually a good argument because flight times should be different on a north-south basis due to the fact that one of them the plane's chasing the target, and the other one you can lead the target.
There is no real chasing the target. There's no real chasing the target. It's
well, if I'm constantly drifting.
Okay.
If the target's moving, like say you're going in a straight line, but the target's moving right of you, you're not going to keep flying straight and then like keep chasing it right. You're going to fly like a little bit so you can do a straight line. They want to do a straight line when they're up there from city to city, right? They don't want to be flying in like curved paths.
You can do the same thing. The amount of adjustment is going to be the same, both north and south. Number of degrees of adjustment, number of miles of adjustment, number of whatever. But yeah, wind would have some effect, but that wouldn't affect the MEMS acceleration. The MEMS would be independent of wind.
But wouldn't you start off like, okay, let's say you're in Canada, Alaska or something, and you're flying to the equator. Wouldn't you start off leading the target so that your plane can fly in a straight line, but by the time you get there, the city's going to be underneath you. You don't want to be flying in a curved path, getting knocked over by Coriolis.
You don't fly in a curved path. You fly in a straight path on the Earth. You correct for it. Fuck.
Right. You're constantly correcting for it. Like you're trying to stay on the latitude line.
A plane is not a plane. A plane is not a plane is not ballistic. There are pilots driving it. There's a machine driving it, the autopilot. It's not a fucking bullet. It's not a shell. If it was a bullet or a shell, you'd have to lead it. But no, it's not.
I understand, but you don't want to be you don't want to be having your pilots constantly correcting. That would mean you'd be flying. That means you'd be flying in a curved path when it was all said and done. Don't they want to?
Path over the face? It depends on your reference frame. Your reference frame to the Earth is a straight line. Actually, it's a curved line on a straight map, but it's a straight circle route.
So do they pull up? Do they? Sorry, guys, just 2 seconds. Do the pilots pull up or do they push down?
They don't.
They don't do either.
Are they extending? Or are they just
cruising altitude?
Cruising? No, stay level flight.
Stays level.
Yep.
So naturally, what's happening is as the ground is moving away from you, naturally as the ground's moving away from you, you're going to go off to space, aren't you?
No, because you don't know how airplanes work.
Yeah, well, I do know because they
don't know how airplanes work.
They alter for the elevation, the local elevation. So naturally, if you're saying it's staying level, then surely it's not altering for the local elevation. So
once again, when you say stupid shit like that, you don't know how airplanes work. This is a common FLIRF problem.
I'm not FLIRF. Don't they say they work in a pressurized line, maintaining that
2.5 degrees
above and below, which keeps them level, regardless of what that level terminology is. Isn't that how they work?
I read up that flying level is actually flying slightly goes up, and it is cruising at an air pressure gradient, essentially.
Yes, exactly.
Power is the only thing you can go up or down.
And it doesn't really matter what especially these airliners are designed to be so the cabin is level at cruising altitude, so the wings are somewhat canted to the fuselage. So it's not the fuselage that matters; it's the wings.
Mm.
So I read up they like tilt up 2.5 degrees, but someone said it somewhere, but I don't know how over what distance, because that sounds ridiculous anyway. You know, you'd be having to anyway, but they definitely don't tilt up. They go according to elevation, but elevation is going to change. They know they don't need to adjust. But this 2.5 degree tilt up. Concorde. What was was Concorde the same?
Well, they've got to slightly tilt up because otherwise they'd be constantly falling out of the sky, wouldn't they?
No, because of the curvature going down. There's your lift. You don't need to do anything.
No. They're flying in a pressure zone. That's how they fly. They're in a zone, apparently.
Flight is a balancing act.
But naturally, if it's curving down, then the waves and the pressure and all that's sorted out for you, isn't it? But you have to adjust a bit more.
On the globe model, that pressure zone would be consistent all the way around the globe, wouldn't it?
Yeah. But even
give or take a few hundred feet.
Right. The same with your concave Earth. The pressure zone would be consistent all the way around on the inside.
Yeah,
there'd be different layers of it.
I know the equator, the atmosphere is closer to the equator, like stratosphere, ionosphere. They're closer.
No, it's the other way around.
They're further away.
Further away at the equator, they're closer at the poles.
No, magnetic equator. How about that?
Magnetic equator. What the fuck is that?
Oh, I've got to go, man.
I don't know. It sounds like something you made up. Do you have any evidence? Anything shows it? I mean, I could.
The fact that they tilt up, is that proof of concave Earth?
Actually, I'm sorry. I wanted the clarification because I've heard him say it a lot, and now I've heard somebody else complain about it. What the hell is a magnetic equator? I don't think I've ever heard it. Is it just the halfway, essentially the halfway point between the poles? And does it have any significance in any utility in our world?
Magnetic west. I've heard RC references before. Magnetic west. My bad, man.
No. You're right. You're right. He's looking at the elliptical orbit of the sun and how it's moved over a long time, and it's moving. I think it's something.
Well, we know that the magnetic north doesn't line up with the celestial north or the axial or the geographic north. So we're assuming that west doesn't line up either, right? It can't. I mean,
west. There is. What is west?
That's what he's asking. Is it according to your compass? According to the compass, is according to where the sun sets on the equator? Is it 90 degrees from the north? Like which west? There's a whole bunch of different
west
norths.
Is always there's not a whole bunch of different norths. There's a couple of different names for the same thing. There's a magnetic north and a true north, and those have other names that they go by.
And they're not the same; they're different. So is grid north and celestial north.
As far as I know, the magnetic, celestial north. Is there any difference to celestial north than true north?
Well, they say celestial north is the axis above that. Is the spot where Polaris rotates around. But whenever you look at it, you don't look at that spot. You just look at Polaris. So you wouldn't be exactly quite on either. You can't look at a blank spot. You can't look at Polaris and be like, oh, that's where that's the spot it rotates around in the sky. You know what I mean? You're just gonna look at the star and be like, there's fucking north.
Celestial north and geographic north are the same place as far as I'm concerned. I could be wrong, but
yeah. But if you're looking at Polaris, it's
not fictitious. The imaginary point. No, it's actually the physical point where the Earth rotates on, and that doesn't necessarily correspond to any star.
Okay, I don't want to get bogged down on that, but magnetic north and true north are definitely not the same. So west would be off too, right?
Right, but we have a uniform method that has worked for centuries called geographic north, and there's not much reason to go to magnetic north, which is a variable that varies both by your location and by over time. So it's just this thing that wanders all over the place. It's kind of a pointless thing to use as a standard.
Oh, that's what the realm was trying to figure out. Are you using a compass to figure this out, or like what were you using?
That's like using the wind to determine, I normally get a north wind, so I'm going to use the wind to determine my direction.
So realm, they weren't
today
using.
It wasn't coming from the north.
So you weren't using. So you're using the 90 degrees from north when you said west. 90 degrees from 90 degrees from geographic north.
Yes, you mirrored realm.
I don't know. I was just trying to clear. I don't even remember what you guys were talking about at this point.
Yeah, no. What I would call west, the most uniform place to call west would be 90 degrees from geographic north.
Yeah, there you go, realm.
He's not here anymore.
And it only applies on one line of longitude. It changes between as you go.
I'm telling you, I'm pretty sure flight time should be different from a northern to southern flight than a southern to northern flight, as long as you stay on one side of the equator, bro. It would have to be in the globe if they're constantly adjusting. Like
I don't see how, because essentially well, let's see. I could see fuel use might be different. Let me think about that.
Well, one of them.
Yes, one
you're
may
going to
have to accelerate, and no, they're both perceived as accelerations. So I can't see anything. You've got to make up going between 40 and 50 degrees longitude. You have to make up, I think 148. Yeah, 148 miles per hour in an hour. So
if you're gonna
north or south, you have to make up 48 miles per hour.
So I'm saying if you're gonna fly somewhere, you're gonna want to fly in the straightest path possible, right? So you're gonna lead your target for where it's gonna be by the time you get there, right? They got this all figured out.
All you do is essentially, I mean, outside of wind and stuff, if I just parked on the latitude line, just aim there, and I turn my rudder, a couple of degrees, a half a degree, a quarter degree, whatever. Now I can follow that line all the way down without making any other adjustments.
So you're saying there's no Coriolis if you follow a latitude line, bro? That's crazy.
No, I'm not saying there's no Coriolis. You have to adjust your rudder. You adjust your rudder.
Okay, listen to me.
The longitude line.
Listen to me. If you're flying a plane, you want to be flying in a straight line path to your destination, right? So you're not gonna let Hawaii or whatever city you're shooting for from Canada. You're not gonna let it keep going in front of you, in front to the right of you, and just keep curving your path and just be chasing it. You're gonna be flying in the straight line so that when you get to your point, it's under you, right? They're not going to just fly from Canada to. They're not going to just fly from Canada to Hawaii, facing Hawaii the whole time if that's the direction that the thing's happening in. They're going to shoot. They're going to.
Let's use my wind analogy. Let's use my wind analogy on flat Earth. Okay, I've got wind. I've got a 2 mile an hour crosswind, and I want to go straight between two cities, north and south. Right? What do I do with my airplane? Do I aim way ahead of the city, or do I just turn the plane to account for the 2 miles per hour?
You would aim your plane.
Straight,
they want to
sort of sideways.
You would aim your plane for where Hawaii is going to be. You do all the math, account for the Coriolis and shit, and you would make sure that when you fly in a straight line, it's going to be under you when you reach that point. You want to be flying in a straight line. You don't want to be flying curved paths all over the place, chasing shit. That's unnecessary. You just want to be going in a straight line.
That's I don't understand how you're not understanding this. There's no curved path, and let me see if this picture will help you at all.
If you go out in a plane and you start flying towards, say you're in Canada and you start flying towards Hawaii, you're either going to be, which direction it is. If you're going north, would you be leading it, or south, or whatever? Which way is the drift if you're going south? Is it clockwise in the north or counterclockwise?
I have to think about it every single time. So,
just which way do hurricanes and shit spin in the northern hemisphere? Is it clockwise or counterclockwise?
I think Jeremy's trying to say, like, if you're going in a straight line, why do you have to keep turning to the same direction? If you're doing that constantly, it's not a straight path.
Yeah, if there was actually Coriolis, you would be flying at a crazy angle towards your city. People would be like, "Yo, why are we flying in this direction?" You'd be like, "Don't worry, we gotta lead our target because we're trying to fly in a straight line, and by the time we get there, the Coriolis effect will make it so that Hawaii's underneath us because there's drift." Like, you would see this happening in planes if you took a northern to southern flight. You're not going to just be chasing Hawaii the whole time.
Look at the picture I just posted. I've got a wind coming from the west, blowing east. My airplane, in order to fly on that straight line and to stay on that straight line, will just turn itself with the rudder slightly.
You didn't post anything.
West.
Yeah.
You didn't post anything.
Okay, I'm sorry.
Oh God, you always got these crazy. Okay, what are we looking at?
Yeah, but just suppose there was no. What about if there was no?
Flying north, and I've got a wind, which, for lack of a better term, that's what we're talking about. We have to accelerate in a direction. In order to follow that straight path, I am going to turn the plane diagonally to counteract that wind in order to fly in a straight line.
Wouldn't it be better to just fly in a straight line? You could calculate where the wind's going to take you, and you could just fly in a straight. I mean, this is a predictable wind. This is the ether.
Does it blow you where you're going?
This is the Coriolis wind you're talking about, right?
That would be long. That would be a long. No, I'm talking about this just a physical wind on flat Earth. If you're flying in a plane and you have a force on your airplane blowing it off course, you counteract that by turning the plane slightly into that to counteract it.
Okay.
Mm-hmm.
That's the shortest distance. Otherwise, what you're going to do is you want to do some kind of weird zigzag thing where I fly way, and they seem very similar actually, but you think about it. The plane is pointing off course, but it's flying straight.
Doesn't it make more sense to be actually flying straight than to be like fighting a diagonal wind, like flying diagonal to counteract this other force? That's like, I don't understand why they wouldn't just use this to their advantage.
Extra miles. If I do it your way, which I'm not sure what your way really is, but if I do it your way, kind of like, and I fly west, and I actually cover ground more to the west, like I actually physically go west instead of following this straight line, I'm going to cover more miles. It's going to form like a triangle or an arc.
Instead of having to adjust and fly diagonal. Instead of flying diagonally or having the pilots have to correct, or the automatic pilot having to correct nonstop, which would make your path curving at the end of it. If you're constantly correcting for the Coriolis effect, you're going to end up with a curved path.
There would be no curve. There would be no curve at all. It's a dead straight path that you fly by just turning into the wind to counteract the wind.
You actually see that effect at times when planes are landing, when they've got a big crosswind
on a runway.
You see them coming in at a diagonal, but they're actually going dead straight down the runway.
And as far as adjusting, you're constantly adjusting. This would be like a single adjustment. If the wind was always a few miles an hour to the east like this, you would just turn the plane that way, and you wouldn't have to make any adjustments. Now, the fact that wind changes all day long, you're going to have to constantly adjust. That's just the nature of flying.